explorers are sending unsettling data back to Earth. NASA's farthest-traveling spacecraft, Explorer-1, continues its journey across the vast, uncharted regions of the universe nearly 50 years after its launch. Researchers are astounded by the terrifying information this renowned spacecraft has been transmitting as it ventures through deep space. What initially appeared to be a system failure is now part of a larger, mysterious puzzle. The Explorer spacecraft, launched as part of NASA's space exploration missions, continues to send back unusual data. Explorer-1 and its twin Explorer-2 were both launched from the Kennedy Space Center in 1977, with Explorer-1 following shortly after Explorer-2. The two spacecraft, each weighing around 720 pounds, about the size of a small car, were sent on a trajectory to slingshot them from one planet to another, exploring distant outer planets. Though they started from the same location, they traveled on separate paths and at different speeds. On December 15, 1977, Explorer-1 broke free from its twin, embarking on a journey to explore Jupiter and beyond. By 1978, it started its Jovian imaging project and captured over 3,700 images of Jupiter, documenting its rotation and the surrounding moons. It made significant discoveries, including the identification of new moons and rings around Jupiter. It also found 4 new moons of Saturn during its flyby of the planet, including Mimas, Enceladus, Tethys, and Dione. After completing the Saturn mission, both spacecraft were sent into interstellar space, traveling at a speed of 325 million miles per year. In 1990, NASA launched the Explorer interstellar mission, aiming to study the Sun and outer planets. By February 14, 1990, Explorer-1 was 6 billion kilometers from the Sun, and it captured more than 60 images, adding to the spacecraft's collection. Its cameras were turned off to conserve energy before its departure into interstellar space. As Explorer-1 ventured deeper into the unknown, it joined other spacecraft such as Trailblazer 10, Trailblazer 11, and New Horizons on their journeys beyond the solar system. Explorer-1 passed the heliopause, the boundary where the Sun's influence ends, and entered interstellar space on August 25, 2012. NASA didn't publicly announce this milestone until 2013, and by November 2018, both Explorer-1 and Explorer-2 were officially outside the solar system. Today, Explorer-1 is approximately 145 billion miles from Earth and continues to transmit valuable data. Despite its age and distance, the spacecraft has remained operational, but recent reports have raised concerns. The spacecraft is sending strange signals, and its onboard systems, while functioning properly, are transmitting unusual data. The spacecraft is still responding to commands and sending scientific measurements, but the reports it generates don't fully align with expectations. Explorer-1 and Explorer-2 each carry a gold-plated disc containing sound and video messages, including greetings from former U.S. President Jimmy Carter and UN Secretary-General Kurt Waldheim, in case the spacecraft is ever discovered by an extraterrestrial civilization. However, the possibility of alien intervention has been dismissed by scientists. The spacecraft's communication system is designed to keep its antenna focused on Earth, ensuring that data can be transmitted effectively. Despite operating under these conditions, scientists are puzzled by the strange data it continues to send. The spacecraft's survival and functionality depend heavily on its onboard communication and control systems. Yet, none of the safety mechanisms designed to protect the spacecraft from harm have been activated, which adds to the mystery surrounding its current state. The spacecraft, now about 45 years old, is far older than anticipated for such a mission. Experts acknowledge that the age of the spacecraft and its vast distance from Earth present significant challenges in diagnosing and addressing the issues. Given the size and complexity of the problem, fixing Explorer-1 is highly unlikely with current technology, and the team faces tough decisions as they explore what could be the final chapter in this remarkable mission. The impact of cosmic rays on spacecraft is a significant concern for space exploration. These high-energy particles can penetrate a spacecraft's exterior and affect its internal electronics. The longer a spacecraft remains in space, the greater the likelihood that cosmic radiation will interfere with its systems over time. This can lead to unexpected anomalies, such as those observed in Voyager 1's telemetry data. Engineers have long been aware of the potential risks that cosmic radiation poses to both spacecraft hardware and human astronauts. However, predicting and mitigating the effects of these particles can be challenging. Despite these difficulties, engineers have developed several strategies to protect spacecraft from cosmic rays. These include designing radiation-resistant electronics, implementing redundant systems, and using error-correcting codes in data transmission. Despite these precautions, cosmic radiation remains a significant threat, especially for spacecraft operating in deep space for extended periods. The anomalies in Voyager 1's data are not entirely unexpected, given the spacecraft's age and prolonged exposure to cosmic radiation. Researchers continue to monitor the situation and analyze the data from Voyager 1 to better understand the cause of these irregularities and develop strategies to minimize their impact on the spacecraft's operations. Voyager 1, which has far exceeded its original mission expectations, continues to provide valuable data from the outer regions of our solar system and beyond. Its success is a testament to human ingenuity and our relentless pursuit of exploring the unknown. As we look ahead to future missions, spacecraft like Voyager 1 will continue to inspire and expand our understanding of the universe. Launched on September 5, 1977, just 2 weeks after its twin Voyager 2, Voyager 1 embarked on a journey that has taken it far beyond the boundaries of our solar system into the vast expanse of interstellar space. The Voyager missions were a demonstration of human creativity and exploration, designed to capitalize on a unique alignment of the outer planets that enabled an extraordinary flyby tour of Jupiter, Saturn, Uranus, and Neptune. The spacecraft provided groundbreaking insights into these distant worlds. Voyager 1, in particular, made remarkable discoveries during its close flybys of Jupiter and Saturn in the late 1970s and early 1980s. One of its most significant achievements was its study of Jupiter's moon system in 1979, where it captured stunning images and data of the planet's 4 largest moons: Io, Europa, Ganymede, and Callisto. These moons revealed dynamic volcanoes on Io, frozen surfaces on Europa, and the possibility of a subsurface ocean, sparking scientific interest in the potential for life beyond Earth. After its success at Jupiter, Voyager 1 continued its journey toward Saturn. In 1980, the spacecraft passed near Saturn's intricate ring system and fascinating moons. Its observations provided detailed images of Saturn's rings, uncovering complex patterns and interactions among the ring particles. Voyager 1 also discovered new moons around Saturn, enhancing our understanding of the planet's diverse satellite system. After completing its primary mission objectives at Saturn, Voyager 1 entered a new phase of exploration. Its trajectory took it away from the plane of the solar system, heading toward interstellar space. In 1990, Voyager 1 captured the iconic pale blue dot image, where Earth appeared as a tiny speck in the vastness of space. This image poignantly illustrates humanity's place in the universe and remains a powerful symbol of the enduring legacy of the Voyager missions. Despite the challenges posed by the harsh environment of deep space, Voyager 1 has continued to send back valuable scientific data. The spacecraft's instruments have measured cosmic radiation, magnetic fields, and plasma waves as it crossed the heliopause, the boundary marking the transition from the solar wind to the interstellar medium. In 2012, Voyager 1 officially entered interstellar space, becoming the first human-made object to reach this milestone. Voyager 1's longevity and resilience have far surpassed expectations. Originally designed for a 5-year mission, the spacecraft has been operating for over 47 years, powered by its nuclear generators. These power sources have sustained its instruments and communication systems, enabling ongoing scientific investigations in the distant reaches of the solar system. In recent years, however, Voyager 1 has encountered anomalies in its telemetry data, raising concerns among mission scientists. These irregularities are believed to be caused by cosmic radiation affecting the spacecraft's electronics, which poses challenges for mission operations. Cosmic rays, high-energy particles originating from sources such as supernovae, can penetrate spacecraft and disrupt sensitive electronic components. Over time, prolonged exposure to cosmic radiation can lead to unexpected malfunctions and data anomalies. NASA engineers have implemented various techniques to mitigate the effects of cosmic radiation on Voyager 1 and other deep space missions. These include shielding sensitive hardware, using redundant systems, and developing error-correcting codes for data transmission. Despite these measures, the unpredictable nature of cosmic radiation continues to present difficulties for spacecraft operations in deep space. The anomalies in Voyager 1's telemetry data have required a thorough and methodical approach from mission managers. Engineers have conducted extensive diagnostics and simulations to identify the root causes of these irregularities and develop potential solutions. The spacecraft's remote location, about 14.5 billion miles from Earth, adds to the complexity of troubleshooting and resolving issues in real time. Nonetheless, Voyager 1 continues to serve as a testament to the enduring legacy of human exploration, providing invaluable data from the farthest reaches of space. As scientists continue to study the spacecraft's condition and the challenges posed by cosmic radiation, Voyager 1 remains a symbol of humanity's determination to explore the unknown. Explorer 1 has traveled far beyond the range of any contemporary spacecraft, and maintaining communication with it presents significant challenges. Its journey has taken it into the farthest reaches of space, far beyond the realm of our solar system and into interstellar space. As it continues to travel further from Earth, it takes nearly 21 hours for messages sent at the speed of light to reach its current location. The spacecraft's distance from Earth creates a significant delay, making real-time troubleshooting and problem-solving difficult. Once Explorer 1 receives commands, the return messages will take another 21 hours to reach Earth, resulting in a total round-trip communication delay of about 2 days. This makes it extremely difficult to execute short-term fixes or iterate on troubleshooting procedures that are crucial for addressing complex technical issues. Unlike new missions on Earth where engineers can quickly send and receive instructions, the long communication delay with Explorer 1 requires a more careful and strategic approach. Each command must be meticulously planned to address potential issues without causing further complications. This extended delay means that engineers can only collaborate with the spacecraft at limited intervals, making each transmission critical. Every order must be precise and effective, leaving no room for error. This demands thorough review and approval of commands on Earth before they are sent to Explorer 1. The spacecraft itself is over 40 years old, having been launched in 1977, and is now operating with technology and systems designed in the 1970s. This adds another layer of complexity to its operation. Additionally, the harsh conditions of space have taken a toll on the spacecraft's systems. For more than 4 decades, Explorer 1 has been exposed to cosmic radiation, extreme temperatures, and micrometeoroid impacts, all of which contribute to wear and tear on its components. This makes maintenance and repair even more challenging. Despite these difficulties, the engineering team remains committed to resolving the issues Explorer 1 faces. They are exploring various theories about what may be causing the anomalies and are running simulations on Earth to test potential solutions. This careful, methodical approach is critical, as any incorrect command could worsen the situation or result in a loss of communication with the spacecraft. The team is also making use of the spacecraft's redundant systems, which were designed to increase its resilience to failures. If a particular component is malfunctioning, the team can switch to backup systems to restore normal operations. In summary, diagnosing and addressing the issues with Explorer 1 is a monumental task. The engineering team is relying on their expertise and the spacecraft's inherent redundancy to tackle the challenges. Their meticulous and patient approach is essential in managing the long communication delays and the complexities of working with a spacecraft that is both distant and aging. Despite the odds, their efforts aim to continue Explorer 1's legacy of scientific discovery, far beyond its original mission parameters. The glitches may be the result of high-energy cosmic rays affecting the spacecraft's delicate electrical systems. These particles, originating from distant supernovae or other large cosmic events, travel through space at nearly the speed of light.